Hey, what's up and how's it going? My name is Toby, and in today's video we are going to build this simple yet beautiful AR game using the Unity engine. And as you can already see in this game, you can on the one hand build some kind of tower or some kind of building and then shoot it down using a sphere. And as this video is beginner friendly, we're going to learn everything step by step, from creating a new Unity project, installing all of the necessary AR packages, and then coding all of the logic together. However, I highly recommend to have a little bit of prior experience using Unity. So if you have never used Unity before and never coded before in C#, then I'll link something in the video description so you can get started with Unity first and then get started with AR in Unity. And if you've done this tutorial, if you followed all the steps, you can take this prototype anywhere. You could introduce some kind of shared AR, so multiplayer. You could make it a location-based experience so that you'll have, well, different challenges at real-world locations. I also made tutorials on both of these topics. Or you could introduce some kind of high score system or whatever you want. So with this knowledge, you'll be able to build a lot of AR applications, and this is exactly what this beginner-friendly tutorial is for. Alright, so without any further ado, let's get started. Alright, so let's begin by creating a new Unity project, and I have installed the editor version, or better said, I'm going to use the editor version 2022.3.35. So this is the 2022 LTS version, and any 2022.3 version should work, but if you want to be super sure, then please use the same version as I do. And of course I have the Android and iOS module installed, so if you install the editor, or if you've already installed it, you can click here and you can add modules, and then, for example, select the iOS or Android build support. And if you install the editor newly, you can of course hit install and then select the platforms that you want to add. Alright, so then let's create a new project and let's select the URP template, so the universal 3D, and we want to call this one, let's say, Angry Cubes. And then we can choose a location where we want to store the project. So then select the folder, and then finally select some kind of organization and create the project. Alright, so the project has loaded, and now the first thing that we want to do is we want to switch the build target, and for that we can go to File, Build Settings, and then we can simply switch to either iOS or Android depending on what kind of platform you want to build to. So click Switch Platform. And now if we go back to the build settings, we can confirm that we successfully changed our platform to iOS in this case. Alright, so then next up we want to install AR Foundation. For that we can go to our package manager and click on Window, Package Manager. Then we want to go to the Unity registry, and then let's search and select AR Foundation here and click on Install. Then we need to switch to the new input system, and for that we're just gonna click yes, and the editor will restart. Awesome, so next up let's quickly go into our project validation and make sure that we will select all the right options for our AR scene. For that we can simply go to Edit, Project Settings, and then within the XR plugin management down here, we want to select the correct plugin providers. So for iOS, we're going to use ARKit. Then for Android, we're going to use the AR Core. And finally, on the desktop or standalone, we will use the XR simulation. Then next up, let's go to our project validation setting here. And let's go to iOS, simply click on Fix All, and to Android, and then also click on Fix All. So these are some settings which will be changed in order to make it possible to build to our device, and these are settings which you would find in the build settings and the player settings under the other settings. For example, for iOS, it's filling in the camera usage description. And we also have the microphone and location usage description here. So we don't need to fill out these, but if you're interested in what this fix all is doing, it's basically also doing some setup here within the Android tab, where it's going to, for example, set the scripting backend to IL2 CPP and some other settings that a bit earlier we had to do manually, but is now being done automatically. So next up, let's set up our scene. And for that, first of all, we want to delete the main camera. And then we're going to do a right click, click on XR and create an XR origin. So this is kind of the camera for our AR scene that we're going to use. And then next up, we're going to also create an AR session. So this will, kind of control when the AR scene actually starts and ends, and will just run some backend function to make sure that all the stuff that is working in AR, like the tracking of the image, for example, or tracking the motion sensors of the phone, will correctly work. So then next up, what we want to do is we want to also add an event system. So let's go to UI and let's add the event system and replace this with the input system UI module. And then next up, what we want to do is we want to activate our XR simulation. So for that, let's go to Window, XR, AR Foundation, XR Environment. And this is basically a way to test augmented reality in the editor, so we don't have to build to device all the time. And to make this, a bit more realistic, let's import our sample environments like this. And now there will be a little window popping up any second. So then let's click on import. Awesome, and now we see that we already have a different environment here, and we can later on just test out our AR scene within this environment, and you can also choose from many different other options here, but we're gonna leave it like this for now and simply close the window. As we're using the universal rendering pipeline from Unity, which allows us to add some more advanced rendering effects later on if we want to, but which is also just the modern option for rendering, we'll need to adjust one more setting for our AR camera, and this we will find in the setting. And here we have a few rendering presets for URP, which can be used for different kinds of devices. So we have a balanced, high fidelity and performance. And here we could just adjust some graphical settings, for example. However, what we want to do here is we want to go actually to the renderer, and we want to add a renderer feature which is the AR background renderer feature. And if we don't add this, then our screen will simply stay black. So let's add this feature to each of these renderers like this. And now let's simply test out and, of course, save our scene by hitting Ctrl S and test out whether the XR simulation is working. Cool. So if we look around, we can see that we are in a XR environment. The lighting is a bit too harsh, so let's tone that down, but we can move around and simulate what it would be like to move around in the real world with the WASD keys and with right click on our mouse. So then let's stop again. Let's turn down the light to something like maybe 0.4 or something. Nice. And now let's add plane detection, so we have some kind of environmental understanding. For that, let's click on the XR origin and let's add a plane, so an AR plane manager like this. And let's also add a AR raycast manager. And basically the plane manager is going to, as it says, create a virtual AR planes within our scene. And then the AR raycast manager will help us to interact with these planes. So if we, let's say, tap or click on the screen, it can shoot a laser beam raycast onto the AR planes, and then we could, for example, place an object wherever the laser, wherever the raycast hit the AR plane. Alright, so next up we'll still need a plane prefab. So for that, let's simply go to our hierarchy here, do a right click, and let's go to XR and create an AR default plane. And let's simply drag this into our assets to make it a prefab. Then let's delete this. We can also do a right click and delete, or hit Control and backspace. And then let's do a double click on our AR default plane. And here we also have this thing with the universal rendering pipeline. So this is still, this material is still made for the old built-in render pipeline. So if we double click this, we'll see we have this pink color, which is not what we want. So we can simply select the debug plane material here down in our assets and go to Edit, Rendering, Materials, and convert the built-in material to the URP. Proceed. And now we'll have a normal material again. Cool. So then let's click on the XR origin and let's drag the AR default plane as a prefab into our AR plane manager and simply drop it here like this. And now if we hit play again, we should see that we have plane detection enabled. And yep, we can see that there's some kind of detection going on. And now we can actually work with these surfaces and interact with them. Cool, so we have our basic AR scene fully set up. So next up, we're gonna import the AR Magic Bar Lite, which is a free Unity asset that I've recently released and which will help us tremendously to get started with our game. So for that, we want to go back into the package manager and go to the assets. So first of all, of course, we'll need to add the assets to our assets. And for that, we can use the Unity Asset Store, and I'll leave a link in the video description. You can simply click on it and then add the AR Magic Bar Lite to your assets. So then let's click on the AR Magic Bar Lite and let's simply import it. Then let's close the window. And then let's simply go ahead and, well, close these folders here and go into the AR Magic Bar folder in our project view in the assets folder. And let's simply drag the AR Magic Bar Lite into our scene. We also have the placement method as mesh detection, and we're gonna leave it like this for now. And we can also go ahead and open up Window, AR Magic Bar, the prefab and image editor here. And we can already see that there is a test cube within our prefab and image editor. And let's test, if we start the scene, what is currently happening. So let's click play. And we can see that this bottom bar here appeared. And if we now go ahead and move around and take a look, if we actually click on this cube, it will highlight. And if we then again click on some of these planes here, it is going to place the cube. And this again has this issue with the material, so we're going to fix that in a second. But we could go ahead and click on the cube and place another one again like this. And if we click on the cube, we can see that we also have the option to move it around like that. So forward, backward, up and down. We can rotate it or even scale it up or down. And of course, delete. So this is the AR Magic Bar Lite, and this is going to basically be at the core of our game prototype that we are going to build today. So then let's quickly fix the issue. We are not going to necessarily use this cube for our actual game. However, we can just do that for some better testing purposes. So let's click on the default material here. Again, edit, rendering, materials, convert to URP, like this. So let's begin by creating our canvas or our UI that we are going to use. So of course we have the AR Magic Bar, which is going to be at the bottom. But we're also going to use a few buttons, and for that, let's do a right click in our hierarchy, go to UI and then create a new canvas. And let's click enter, and let's simply call this one the start, shoot, reset buttons, because this is what we are going to actually do. And then let's do a right click, UI, and let's create a new button, Text Mesh Pro. And for that we need to import the Text Mesh Pro Essentials. So this is basically a Unity package that is going to help us to work with texts and buttons. So let's do that. And we could also import the examples and extras, but we are not really going to use it. So let's simply close the window. And now we have a button, and let's quickly customize it. So the width, let's set this one to, or let's just leave it at 160, but increase the height a little bit. Let's say 40 or maybe 50. And let's duplicate the button, so we can do right click and duplicate it 3 times. And we can already call these buttons start, then shoot, and reset, like this. And then in our start, shoot, reset buttons canvas, let's add a horizontal layout group, so we all have them look neat. And then let's uncheck the child force expand on the width and set the child alignment to upper center, like this. And let's introduce a little bit of spacing in between the buttons, like that. So this looks good. And we also want to do some padding from the top, so it's not glued to the top of the screen and it's easier to reach. Maybe like this. Awesome. So then next up, let's change the name or the text on the buttons. So this is going to be, again, this is going to be start. This is going to be shoot. And this one is going to be reset, like this. Super. So now we have 3 buttons in a canvas. And before we're going to do any kind of scripting and going to create the actual logic, let's first of all create the different components or our different building blocks or objects or whatever we want to call it to get the game started. So within the asset folder, let's create a new folder which we want to call 3D objects, like this. And of course, we're also going to need a few materials. So let's click again on our assets, click create folder, and let's call this one materials, like this. And let's go ahead and create a few materials first. So I'm going to create very simple materials with some kind of wooden color. But of course, you can do it as you wish. And you could also go to the Unity Asset Store or to something like Polyhaven and get some materials out there. Just make sure that they are not too big in file size, so that maybe one material is not larger than maybe 1 megabyte or something like this, because otherwise we're going to get some performance issues, especially at Polyhaven. The materials are pretty big. So let's create a simple material here, and let's call this wooden material 1. And then let's go ahead and simply set the color to something that could resemble some kind of wooden color. So I would say this would be a pretty bright or light wooden color. And let's make sure also to set down the smoothness so it looks like this. Then let's duplicate this one by hitting Ctrl D. And let's call this wooden material 2. And let's simply make this a bit darker, a little bit, and maybe a bit more reddish. That's also fine. Then let's do wooden material 3. Can make this one even a bit darker, like that. And finally, wooden material 4, let's say. and this one could be even darker than this. So we have 4 different materials that we can use. And now let's actually go ahead and create the objects that we want to place and some corresponding icons to that. So for that, let's do a right click in the hierarchy, and let's first of all switch to our scene view. Let's do a right click, create a new 3D object, and let's create a cube. And let's simply call this one wooden block. Again, here we could also potentially go into a tool like Blender or into the Unity Asset Store and get some more advanced stuff. But for our prototype, for our tutorial here, we're fine with just the standard shapes. And let's also create a empty, which we're gonna call the wooden block parent. And this is going to come in handy when we'll later on scale and move the object. Let's move the wooden block into the wooden block parent. And as I already know that in AR, well, basically this 1 by 1 by 1 means 1 meter, which is pretty big then. Let's already reduce the size here of a wooden block and maybe set it to something like 0.2, which would be 20 centimeters. Let's get rid of these gizmos here, like this. And then let's move the wooden block up by 0.1 on the y-axis. So if we now change our perspective to isometric and let's go to the x-axis, we can see that it sits tightly onto the ground plane here, if you want to say so. Then we can move back into the orthogonal, I'm bad at this word, but to the other perspective. And let's go back with our scene view here like this. All right, so then let's apply one of those wooden materials. So maybe let's do material 2, and let's simply drag this here into a mesh renderer like that. And here we have a wooden block. So then let's simply move that into our 3D objects to create a prefab so we can use this later on. And let's delete it from our scene, from a hierarchy view here. So then next up, let's create something like a plank. So for that, let's create a new 3D object, again a cube. Let's again make this maybe, so we want to here not have the scale proportional because this is going to be tall but quite thin. And for that, let's reduce the maybe 2.1 the scale on the x-axis and on the z-axis like this. And let's also make sure that position here is actually at 0, 0, 0 for now. And then we can keep this at 1 meter, so, or maybe at 0.5. So we have a nice wooden block. And then of course on the y-axis, let's set this to 0.25. So then again, we have this sitting tightly and correctly on the ground plane. And then let's, for example, apply the wooden material 1 for this. Let's call this wooden plank. And again, let's create a parent object, so an empty object. Make sure this is at 0, 0, 0. And let's call this one wooden plank parent. And let's drag in the wooden plank like this. And let's again create a prefab. So then let's delete the wooden plank parent. And now let's go ahead and create a plane. So for that we are going to use another cube. We're not going to use the plane because, well, if we have some more area to work with, it's easier with the colliders than having just a completely flat plane. We wanted to have a little bit of height. And let's call this one wooden plane. And again, let's first of all go ahead and disable the proportional scaling. And we want to set, first of all, the Y height to something like 0.1 or even 0.05, which would be 5 centimeters, still quite big, but let's work with that. And let's make it 0.2 or yeah, 0.25 again times 0.25 like this. And let's make sure that the position again is 0, 0, 0. And then the height on the y-axis, make this 0.025. So then again, let's check. And yep, it's sitting tightly on the ground plane like this. I think we could even make this a little bit flatter, so 0.025, and then let's adjust the height to 125 like this. So we'll have to adjust these later on, of course, as well, but for now let's keep it like this. And then let's create a wooden plane parent again. So wooden plane parent. And let's reset the transform on the top right here. Let's drag in the wooden plane. And then let's take the material 3 and drag it on here. And then let's create another prefab like this. And we can delete it from our hierarchy. Cool. So then finally, let's create a roof. So for that, let's go ahead and actually install another package, which is the Unity Pro Builder. So for that, let's go to Window, Package Manager. Let's go to the Unity registry and let's search for the Pro Builder. I think it's Pro Builder, isn't it? Pro Builder. It's Pro Builder, okay, but it's written together. So let's install the Pro Builder. And then let's additionally in the samples install the Universal Render Pipeline support. Alright, so then let's close the package manager and actually go up to Tools, Pro Builder window. In the settings, let's use the icon mode. And then let's go ahead and, so let's open the window again, like this. Let's go ahead and actually create a new shape. So we should have this create shape menu here. And for the roof, we are going to, for example, create a cone. So for that, let's click on the cone. Let's simply, drag our mouse over here and drag this one maybe like this, and then increase the height a little bit. And I think that should be enough. So now we actually do have a cone here, which is quite nice. Let's actually reset the position to 0, 0. Oh, and of course the pivot, so the origin here is kind of out of place. So we'll need to again open our Pro Builder window. So let's actually put that somewhere where we won't lose it. Let's simply dock it to our UI here. And then let's go ahead and reset the pivot. I think it's this option. So set the pivot of this point to the center of its bounds. So if we click here, then we can see pivot is doing well. So let's simply, set this to 0, 0. And this one is already set correctly onto the, the ground plane. And let's create a new parent. So let's call this simply wooden roof. And let's create a new empty, and we want to call this wooden roof parent. Let's put in, let's also make sure, of course, this one is at 0, 0. So let's reset. And let's put in the wooden roof object into here. And of course, finally, let's take the material 4 and add that to the wooden roof. Cool. So now we can prefab this. And we do actually have now 4 different blocks that we can work with. And of course, there's a lot of room for creativity here. So you can pretty much create any kind of component that you want. But I think that's it for now for the Pro Builder. So let's close the tab here. And so we're back within our normal window without these menu options here. And next up, what we want to do is I'm going to quickly check if everything is correctly set up. So the parent is at 0, 0. We have a block here. Again, 0, 0. This is working. this looks good as well, and this looks good too. So what we want to do now is, in order to set it up for the AR Magic Bar, we are going to need to create some screenshots for the icons. So for that we could simply go ahead and click on 3D object, and then here on the right side let's do a screenshot. And I think on Mac it's Command Shift 4, and I think on Windows it's Windows Shift S. So let's create a screenshot. It should be 1 by 1, so in a square format like this. And let's drag the screenshot into our 3D objects, and let's call this one wooden block, and then maybe icon. And let's set this as a texture type to a sprite 2D and UI, and let's hit apply. Of course, we can make this more beautiful. We could do some renders. We could even fire up Blender and do something with it, but for now this is going to be fine. So then let's do the same thing with the wooden plane. So let's do a little screenshot here. Let's drag it into our 3D objects like this. And then let's set the texture type to sprite 2D and UI. And let's simply hit apply. Let's call this one wooden plane icon. Alright, and then let's do the same thing with the plank. So we can even move this a little bit so it will fit into our frame like this. Again, drag it into our 3D objects and change the name, wooden plank icon. Texture type 2D and UI. And finally, wooden roof. So this one is, as it's using the Pro Builder, we do not have this nice preview here. So all we can do is just open it up and do a 1 by 1 screenshot here like that. I think this is fine. Again, drag it in, and finally name this one wooden roof icon. And then of course set the texture type to sprite 2D and UI. Alright, so now we have our 3D objects set up, but one more thing that we actually need to add is, as we're using physics, we need to add a rigid body. So these objects do already have a collider added by default, but if we want to actually use physics, then we want to use a rigid body. And what we want to do is we want to set it to kinematic at first, which is going to ignore all of the physical calculations, as we only want to activate physics after we are done building the actual tower or whatever we want to do. So let's quickly do that for all of our stuff here. So wooden plane, add the rigid body, set it to kinematic. Then the wooden plank, click on it, set it rigid body, set it to kinematic, and finally the wooden roof. And we'll also want to set this actually to a convex mesh collider. This has something to do as it is not a standard shape, but this is not something we need to worry about. Just make sure that it's set to convex, and then also add a rigid body and make it kinematic. All right. Next up, let's go back to our prefab and image editor that we opened up here from our AR Magic Bar. Let's delete the cube because we will not need it anymore. So let's hit delete, and let's add 4 pairs of prefabs and icons. And let's simply now drag in here our 3D objects. So like this, like that. So the plane, and then the plank, and finally our roof. And if we're done, we can hit create placeable objects like this. Will take a second or two. And now we have actually created the objects which will then appear in the AR Magic Bar at the bottom of our screen. And to see where those assets actually got created, we can do a double click on the database here, or one click seems to be enough. And if we go to our inspector, we can see that we do have 4 placement object SOs. By the way, if we ever get some kind of error message from the AR Magic Bar, it might be because in this placeable object database there's a missing scriptable object, and here you can simply remove it. And we can already see, if we click on here, that within the resource folder and the placeable objects, we do actually have a new prefab which has the placeable, basically a placeable name at the end. And we also have a corresponding scriptable object. And if we double click now on this object, we can see that, well, we now have the new objects with all the gizmos attached to it, and also our actual parent, our actual clone. And here we can already see maybe, well, this cube here could be a little bit too small. Let's check out the other ones. I think they're not too bad, but we actually need to find out. So this is something that we want to do now. Let's actually find out if the size of the objects is working great for us, or maybe we'll need to do a few changes here, and if they're actually being placeable. So for that, let's switch to the game view, and let's hit play and test whether the AR Magic Bar is working. So we can already see below that we do have 3 of our 4 objects here. And if we do click on this arrow, we can paginate on the second page. And here we have also the roof. And we can actually see that for some reason the material of the plane got resetted. This might be because it was within the packages folder and not within the assets folder. So let's actually quickly test if we can place down our objects and then do something about this plane material. So let's click on one of the objects, let's place it, and yep, it's working. Let's place something on top, working too. Let's place the next object, and now finally the roof. And yeah, we have a tower here. And now if we click on one of these objects, we can see that there's the menu. Click on it, can actually move it around, close it, click the next object, move it around. And because this is a missing material here, it will overlay on all of the other materials here, but we're going to fix that in a second. But we can see that things are working. Awesome. So then let's pause or stop the scene here. And we can actually go ahead and change the material on the plane to a Shadowcaster. So we do not actually have some kind of color, but rather only, well, the shadows that are being casted by our 3D objects. And for that, let's go to Window, Package Manager. And here I'm actually gonna add another free asset, which is created by DevDunk Studios. Or I don't know if it's Studios, but by DevDunk, and it's called the AR Shadow Receiver URP. And there'll also be a link in the video description. You can add this asset for free to your Unity assets, and we'll simply import it like this. And so let's close the package manager once this has been done. And now if we do a double click on the AR default plane, we can actually go into, well, let's first of all lock this view here so it won't change. And we can go to the DevDunk Studio and the Shadow Receiver URP, and there's demo and materials. And we're simply going to take the shadow receiver or the opaque shadow receiver and drag this onto our AR default plane. And now if we go ahead and actually play, we'll only see the outline of the planes, which we can also remove later on, but I think now it's good to understand that plane detection is actually working. And now if we place our assets, we'll see that there'll only be a shadow, and I think this is our camera here, which is for some reason casting a shadow, but I guess in the actual scene this is not going to be this way. Awesome. So now we're testing out our assets, and I do think that actually the plane is indeed a little bit too small. So I think we could make this a little bigger so it will be a bit easier. But maybe we'll also do this later on. Maybe also the planks are too big. So let's actually, before we change anything here, let's create the other logic and then later on change our assets. If we wanted to change them right now, we would need to actually go into the AR Magic Bar and then double click on our Placeable Objects here. Go into scene view, of course, and then we could, for example, simply go ahead in the wooden block and scale this one up to 0.3, and then of course make sure it's on the ground, so 0.15 on the Y, so it's just half of the Y axis in this case. And that would be a way to, well, rescale. But let's first of all do some other stuff here. Let's get into coding next. So for that, let's create a new empty object. Let's call this one game logic. We can reset the position. It doesn't really matter, but still let's just do it. And let's create a new script. And for that, first of all, let's create a new folder within our projects and our assets, which we want to call scripts. And here we can do a right click and create a new C# script. And let's call this one UI button handler. And this one is going to take care of the 3 buttons we created earlier and is going to invoke an event anytime one of those buttons is being clicked. So let's double click and open this one up in our IDE. So I'm using Rider as my IDE, which is a paid coding tool, a paid developer tool. However, there's also Visual Studio Code and of course Visual Studio, which are great free alternatives. Please note though that Visual Studio is not supported, I think, anymore on Mac or will be discontinued soon. So if you're using Mac and you want some free tool, then you can use Visual Studio Code and install the C# and Unity dev tools. Alright, so let's get started with some serialized fields. So for that, let's create a new serialized field for our buttons, and those serialized fields, they will allow us to later on drag in our buttons, so we do have a reference to our start button as well as our other buttons. And it already says that, well, we'll have to import a namespace here, and we want to import the Unity Engine UI buttons, and so it's going to add this using Unity Engine UI on the top here. And now we're going to simply duplicate this twice, and one will be the UI shoot button, and the last one will be the UI reset button, like this. So we have a reference to all of our 3 buttons here. And next up, we are actually going to create 3 events. And events, you have to think of something like a newsletter, some kind of email newsletter where you can subscribe to. So basically, a script is going to send out a newsletter or a mail newsletter, and any other scripts or objects can subscribe to this newsletter, and based on it being sent, execute some kind of action. So for that, let's create a public static event action. And we're going to call this on UI start button clicked. And we can already see that we'll need to import another namespace here. So this is going to be system or system.action up here. And we're going to again duplicate this 2 times. So we have the start button clicked, the shoot button clicked, and the reset button clicked, like this. So then in our start method, we want to add a few listeners for the buttons. So we're going to say that UI start button on click add listener. So if we click the UI start button, let's create a new method down here, and let's call this one on start button clicked, like this. And we want to paste this method here into the add listener. So then next up, let's also do the same thing for the other ones. So we do have the UI shoot button and the UI reset button like this. And of course we'll also need 3 different methods. So we have the on shoot and the on reset button clicked like this. And we'll also need to, of course, paste those methods in here. Great. So then at the on start button clicked, we of course want to first of all go ahead and actually invoke the event. So the on UI start button clicked. First of all, we want to check if this one is null. And if not, we want to invoke this. So this is kind of, we will check whether the newsletter is existing. And if so, we want to send it out to anyone who's subscribed. And of course, we're also going to do the same thing with the on shoot button clicked. So we can also simply copy paste and change the name here. Oops. And the UI reset. Cool. So next up, of course, we'll also want to handle some of the button's visibility, because in the beginning, we only want to see the start and reset button. The idea is, as you probably already saw, that with the start button, we'll trigger the gravity and physics. And then with the shoot button, we'll be able to shoot a ball. But if there's no gravity or physics, then of course we do not want to shoot anything. And with the reset button, we'll go back to the state where we can actually, start the game and go back building. So for that, in the start method, let's begin by actually disabling the UI shoot button. So UI shoot button and then game object set active to false. So we are not able to see the button. And as we earlier on used the horizontal layout view, it will automatically then move the 2 remaining buttons together, so there's no empty space. And then we can go on start button in the on start button clicked method, and let's go to the UI start button. And we want to actually set this one to being false, so being not active, right? So in the beginning, we do not see the shoot button, but once we click start, we are going to actually not see the start button anymore, which is active in the beginning. And we are going to then go to the shoot button and set this one to active as being true. So when the shoot button is being clicked, we don't want to do anything else. However, if we click on the reset button, we do want to show our UI start button again. So we want to set the game object being active, and we want to then, of course, disable the shoot button again. So we have basically when we start out, we have the shoot button being inactive. Then if we start the game, we show the shoot button and we disable the start button. And if we reset, we're gonna basically undo that. We're not going to use the update method in this script, so let's clean this up a little bit so it looks nice and tidy. And that's it. All right, so this is it for our UI button handler script. Let's go back to the Unity editor. And then we want to go to our game logic and attach our script to this empty object, so it's actually being used. All right, so then what we want to do is we want to also drag in our buttons here. These are our serialized fields. And for that, let's go into our canvas and simply take the start button, the shoot button, as well as the reset button. Perfect. So now we have our first script done. And next up, let's create a new script that we want to call enable physics. So make a new C# script and call this one enable physics on, let's say, event, right? So the idea of the script is it's going to be one of those subscribers to our newsletter, so to our events. And based on an event being sent, is going to enable the physics. And the great thing is that we're going to set this script and attach it to each of our 3D objects, which means that all of those objects at the same time will enable the physics. So we don't have to, go through all of them one by one, but we're going to enable all physics at once. So for that, let's go ahead and again create a serialized field, because the rigid body of the object is going to be responsible for the physics, and we'll need to access this in order to activate it. Then let's go to our scripts, which was called UI button handler, and we'll find the on UI shoot button, on UI reset, and on UI button clicked events here, which are basically our mail newsletters. And we are going to subscribe to them by a plus equal. And then we can either create something called an anonymous function, which just does not have any name, or we can do a classical method, which we are going to do. So create a method, and we're going to change the name, and let's call this start gravity or start physics on button clicked, like this. And of course, we don't want a not implemented exception, so an error message. What we want to do is we want to go into our rigid body, and we want to go into the is kinematic setting, and we're going to set this one to false. And we also want to go into the use gravity setting, and we want to set this one to true. And so this will basically activate the physics. Of course, we also might want to delete our objects, and so we'll also need to unsubscribe from our event. So for that, let's go into the onDestroy method. Let's simply copy and paste this one and set the minus sign here. And we want to do this so we don't have any issues later on. So for example, if the object that this is attached to, let's say some kind of wooden plank, is being destroyed, then this will not automatically unsubscribe from this event, and this will cause errors then, because there's no rigid body anymore and we can't actually set anything to true or false. So always make sure to unsubscribe from events, especially if the object that has this script attached to is being destroyed or removed while the scene is running. All right, so that's it, I think, for this script. We can still make sure in the start method actually that the rigid body is actually being set to kinematic, just to be sure, but I think we already did this manually a bit earlier. All right, so this is the enable physics on event script. Let's go back into our Unity editor and actually attach this to our objects. And as we have already created those objects within the AR Magic Bar, we can go into the folder, into the resources, placeable objects, and I will attach this one to our placeable prefabs. So we are going to actually attach this to our wooden block here. So let's search for enable physics on event, and let's put in our rigid body here. Same thing with the plane. So let's close all of this and add the script and drag in basically the wooden plane object, as this is the object that has the rigid body attached, and so it's going to basically get the rigid body reference from the same object. So then we're gonna go to the plank. Let's add the script, drag in the rigid body like this, and let's go to the roof here. The same thing. Add component, enable physics on event, And let's drag in our wooden roof here. Cool. So this is already said and done. So as we have subscribed to our on start button clicked, we could actually try out whether this is working. And for that, let's go into a game view and simply hit play. And we can already see that the shoot button is not available here. So this has already worked. Let's move a bit around and let's place a few objects like this. Something that will definitely collapse. And let's simply hit start. And we can see, yes, physics is being activated. So things are working. Awesome. So then let's stop here again and let's continue with our logic. So for that, let's create another script in our scripts folder, which was here. And we want to call this C# script reset RB for rigid body position of object. And this script, what this script is going to do is it's basically going to, on the reset button, reset the position of any given object. So let's open this one up. And first of all, let's create a serialized field up here. So serialized field, and let's make this one a rigid body, call this one RB. And then also let's create a new vector3. And we are going to call this one rigid body start position. So we want to store the start position of our object. And as we're using physics, we need to do this with the rigid body. And also a quaternion, which is basically storing a rotation. So the RB start rotation, like this. And then in our start method, let's go ahead and again subscribe to our UI button handler, like this. And we want to basically do this on the reset button clicked. So we again want to subscribe to our event here and create a method. So we want to reset rigid body position on button clicked, like this. And what we want to do here is we want to, of course, first of all, in the start method, save our beginning, so our start position. So for that, we want to go to the RB start position variable. And we're going to simply take from our rigid body reference the local position. And this is, of course, since we have the local position, which is the position in comparison, so relative to the object's origin. And we have the world position, which would be, well, the absolute position within the world. Think about it, if you're sitting at your desk right now and looking at the screen, well, the screen might be 1 meter or 30 centimeters in front of you, but it might be compared to the world's maybe 0, world coordinates, it might be somewhere completely different, right? And we want to actually reset it to the local position, which we want to do with storing the local position transform. We also want to do this with our start rotation. So we can go into a rigid body transform, and we're going to take the local rotation, like this. And then in our reset rigid body on button clicked method, we first of all want to set this one to kinematic, so that we do not have any kind of physics going on anymore. And then, of course, we want to reset the start position. So the rigid body local position is going to be set to the rigid body start position, as well as the local rotation is going to be set to the start rotation. And then we also want to go into the velocity of the rigid body, so the speed if you want so. So maybe your object is currently falling down somewhere, and if we just reset it to some kind of position, it still has this velocity and the speed, and this might cause some errors in the future. And then we want to set this one to vector 3.0 like this. And then we also want to take the angular velocity, which is the rotation speed. And we also want to set this one to vector 3.0 like this. And then, of course, well, we don't need the update method, but we shouldn't forget to unsubscribe. So again, in our onDestroy method, what we want to do is we want to unsubscribe from this event like this, and then turn this one into a minus. All right, so now we have our reset rigid body position of object, and let's attach this one to our 3D objects. So then let's go into the AR Magic Bar folder once again and go to our resources, and then again double click on all of these objects, and we can also simply drag our script onto the object and once again get the reference to the rigid body like this. Select the wooden plane, drag and drop, and then also attach the rigid body. Then for the plank, select the actual object, drag the script, and attach the rigid body. And finally, for our roof, let's attach the script to the actual roof object, and once again drag the rigid body like this. Awesome, I think we're good. Yep, I think we're good. And let's actually try if this works. So let's click on play. Then let's start building. So just make it quick. So a few objects. That will definitely crash like that. Let's click start. Oh, it's actually, okay. Let's actually try this one again. Okay, so I think this needs to somehow crash like that. Let's click start. I'm too good. I'm too good. So let's click reset, but we can see that something is happening. Let's try this. No way. It's crashing. Is it crashing? It is crashing. Perfect. So then let's click on reset, and here we go. So we're back, and we could then go ahead and build our tower, and like this, click start, and this is definitely crashing. Click reset, and we're back. And then could go ahead and also move our objects, click start, and do it all over as often as we want. Awesome. And as you might have noticed, if we click on start, we still see our bottom bar here. And of course, we do not want this. We want actually to hide it once we click on start. So let's create a little script to do that. So click create. And let's call this script hide bar on start, and open this one up in our IDE. And what we want to do here is we want to first of all create a serialized field, as always, and take a canvas. This is basically the visual representation then of the AR Magic Bar. Let's call this one AR Magic Bar. And then we can use our handy events that are being fired and subscribe to the UI button handler. So on UI start button clicked, we can simply go ahead and create a new method, and we call this one on start button clicked like this. And what we want to do is we want to go into the AR Magic Bar, so the canvas, and we want to say enabled equals false. So it will be invisible and it can't be used. And then again, let's subscribe to the other event, which would be the on UI reset button clicked plus equals, and then create a new method which we want to call on reset button clicked, like this. And here we're going to then reset the AR Magic Bar to be enabled true, like that. Nice. So let's actually try if this works and go back to our Unity editor. And in the game logic, let's simply attach our script. Then let's go to the AR Magic Bar and drag in our placement canvas here. So then if we hit play, let's go ahead and click start, and we can see the AR Magic Bar is hidden. If we click reset, it's back here. Awesome, so this is working also. Now finally, let's implement the shoot ball logic. And for that, again, we'll need another script, create C# script, shoot ball logic. Then we'll open this one up in our IDE. And for that, let's first of all create a reference to our camera. So let's simply do it in this way. We're going to create a new variable that we call camera and call it main cam. We could also do a serialized field, but I do like this way better, especially sometimes if you use a script or multiple scripts in different scenes, then it can be easier to, well, procedurally or within a script actually get a component than dragging it in. However, what we can actually do is do a serialized field then for our ball object, so ball prefab. And then we're going to do another serialized field for a float, so a number, which we're going to call the ball forward force. And let's set this one to 500. So it's basically the force that we want to shoot the ball with, the speed, if you want. So we can, of course, also change this later on. Then in our start method, let's actually find our main cam. So the main camera is going to be find object of type camera. And this will, of course, only work properly if there's only one camera in the scene. But in AR scenes or in many other scenes, it's normal that there's only one actual camera within the scene. So this is something to keep in mind. So then let's go into our UI button handler and say on UI shoot button clicked. So if we have clicked our shoot button, let's once again create a method here and let's call this one shoot ball on button, for example. Then let's delete this and let's go ahead and actually shoot a ball. First of all, let's create a vector 3, which is going to be the spawn position of the ball, so where the ball will appear. And for that, we're going to take simply the main camera transform position, and we're going to add a little bit of offset, so main camera transform, and then we're going to take the forward, and we're just going to say times 0.1f, and so the transform forward is simply going to be the an arrow pointing forward from the main camera, and we are going to multiply that by 0.1 so that we have a little bit of offset. And then we're going to also take the quaternion, so the rotation and the spawn rotation. This is going to be the main camera dot transform dot rotation. And finally, let's spawn our ball. So we're going to create a new game object and call this one spawned ball. And we're going to instantiate a new, so our ball prefab, add the spawn position and the spawn rotation, like this. And then we are going to also go into the rigid body of our spawned ball. And we're going to, so for that we need to get the component, of course, first of all, of our spawn ball, so that we do have access to the rigid body. And if the rigid body does not equal null, so if we basically remembered to actually put a rigid body on our ball that we're going to create in a second, then we want to add force. So we're going to take the main camera transform forward, and we're going to add the ball forward force. And finally, we also want to add a destroy method. So we want to say that our newly spawned object is supposed to be destroyed after a certain amount of time. So we want to say, for example, after 5 seconds, it should be destroyed. So in this method, we're going to first of all get our position, so the position of the camera with a little bit of offset to the basically the forward vector of the camera. We're going to get the rotation of the camera, then we're going to instantiate the object, we're going to get the rigid body from the instantiated object, and if there's actually a rigid body, so if we actually attach rigid body to the object, then we're going to add a force to it and shoot it forward and destroy it after 5 seconds. So then let's also delete this code here, we won't need it. And let's actually test out if things are working out. So back in the Unity editor, let's also add the shoot ball logic to our game object here. And let's create a new prefab. So let's go into our scene, do a right click, 3D objects, sphere. And then let's reduce the size of the sphere to something like 0.15 or something. And then let's reset the position to 0, 0, 0, like this. And then let's simply do a prefab. So maybe in our 3D objects, let's also add the sphere. And let's delete it from our hierarchy. And in the game logic, add the sphere to our ball prefab, like this. And of course, what I forgot, which I just talked about a second ago, was to actually add a rigid body to the sphere. So this is quite unfortunate. And here we're also not going to set it to kinematic, as immediately as we spawn it, we want it to shoot forward. All right, so then let's go ahead and test. Let's move around. Let's build something like this. And then let's go ahead and put something on here. Maybe like this. It will probably immediately crash, but nevertheless, let's try it out. Like that. And let's hit start. And let's shoot. And yes, we do have it working. Awesome. That is looking great. Now finally, it is time to test this on our device. So what we can do then is go to File, Build Settings, and then either have our iOS or Android platform selected and hit Build. Then we want to set a build folder. So in my case, I actually have a dedicated folder that I call Unity Builds. Let's call this one Angry Cubes. And then we want to do build 1, let's say. And here we can then build our project and load it to our phone. So the whole process is of course different from iOS to Android. For Android it's a lot easier because it will generate an APK file for you and you can simply load this to your device. You need to set it into the developer mode first, but you can simply put the APK onto your Android device and then test it out. For iOS you'll need to have Xcode installed as well as a developer account, which is free at Apple. So I'll put a link in the video description with a lot more detail where you can find out how to do this. So now as the build finished, we can click on the folder, and in this case there's an Xcode project. For Android you'll simply get the APK to install. Want to open up the Xcode project. And then so in Xcode, we of course want to make sure that our phone is being connected. Then we can click on our Unity iPhone tab here. And then within our signing and capabilities, we want to automatically manage signing. And then we want to set the theme to our name or whatever we set for our developer account. And then we can simply go ahead, click play and build this to our device. Alright, and as you can see on the device, things are working great, and it also turned out for me that the scaling was quite nice. But of course, for you it might be different, and if you want to change the scaling of these objects later on, what we would want to do is go into our placeable objects, not into the 3D objects, because when we actually create them with the AR Magic Bar, they will be transferred to these new prefabs, and if you would change something with the 3D objects, well, it wouldn't bring anything. And let's imagine we actually want to increase the size of the plane. We could simply go ahead and go to the wooden plane, then turn on the proportional scaling again and increase it like this. And on that way, we will also have a bigger plane. Then, of course, we want the plane to be flat on the surface. So we would again have to go into our isometric view here, and then actually get, well, basically half of what we have here. So let's, for the sake of this video, let's actually turn this one to 0.8, and then we can do 0.04 to be on flat on the surface. What we could also do, if we think that this gizmo stuff here and all of that is too big, we could go to the placeable object itself and then decrease the scale to something like 0.8 or something, and this will decrease the gizmo size, and then again go ahead to our wooden plane and actually increase the size here. And so in this way could keep the plane size about the same but reduce the gizmo size. And this would be, of course, something you would also then have to transfer to all the other placeable objects. And again, for me, everything turned out to be well. But if you want to customize this later on, then you can do this with this approach. And one final thing that we wanted to do, of course, is to remove these little lines on the AR default plane. For that, we can simply click on the AR default plane prefab. Then we can go into the line renderer, and we'll simply need to drag this red line to the bottom so that it's 0, 0, 0. And then we also won't have these black lines as outlines anymore. Of course, they were quite helpful for developing. Alright, but that's it for this video, so I hope you enjoyed it and I hope you found it useful. If you have any questions, feel free to write a comment below and I'll try to answer them all. And of course, if you enjoyed it, consider leaving a like and a subscription. And the asset that we used, so the AR Magic Bar Lite, also has a full tier version which has a lot of more cool features that you can use to create quickly and easily AR applications and games. So if you like the video, if you like the AR Magic Bar Lite, also consider upgrading to the paid version in the Unity Asset Store. But that's it for today, so thanks a lot for watching and see you next time.